So this is the last part of my design pattern workshop. So yesterday we covered some creational and structural patterns. And so for this morning, we will now cover the behavior patterns, so some of them. So there are quite a few. I will focus on the most famous one, or the one that you can find in many frameworks, and that you can also implement in your projects. Like for instance, the strategy, which is very common, template method, visitors, state. We'll talk about the mediator as well. Memento, this is an interesting one, which is not very common, but as you will see, it's interesting to know about it. So this set of patterns, the behavioral patterns, they play the role of easing communications between objects. So they do something at runtime. Remember, compared to the structural pattern, which enable you to structure or to architecture your code to make it more flexible. In this case, the behavioral patterns, they do something at runtime. They will enable you to simplify the communication between objects, and they will leverage decoupling. So the goal is to decouple objects from each other. I will go first on the Memento pattern. This one is simple, as you will see, and quite interesting. Anyone have heard about this one? No? No one? All right. So, Memento. The Memento pattern, it allows you to extract the state of an object in another object so that you can persist this extracted state. And then from this extracted state, you will be able to recover the state of the initial object without breaking encapsulation. All right? So, as you will see, a memento is an object which captures the state of an object so that it can be saved or serialized somewhere. And then we want to recover or restore the state of the initial object, but without breaking the encapsulation principle. So basically, we don't want to expose public attributes or public setter methods, or we don't want to expose public attributes. We want to save the state in an encapsulated manner. Yeah. So this is how it looks like. You have the client code. This is the class that do things. We have the object that we want to store the state somewhere. This is what we call the originator. So this object has some state, and as you can see, we will have two methods. We will have a method to save the state to a memento, so it returns some memento object, and then we have a method which allows us to restore the state of this object from a memento. So at some point we will have to copy this state, so all of it or just part of it, into a memento, and so this way we will be able to save that memento somewhere, like for instance in a database or in a file or somewhere else. And then we have what we call a caretaker. The caretaker is just the object which manages all the saved mementos. So it allows you to retrieve mementos using an ID or maybe a date. It's up to you. So it's just a sort of repositories of mementos. So if you, I don't know if you can imagine a use case, not in PHP but in softwares. Can you imagine a use case for using a Memento?
You want to check if there is any changes of the state of an entity, for example?
Yeah, for instance, you want to check if an entity's state has changed. That can be something useful. Or making diffs between two states of an entities to check whether you have to resave it or do nothing, for instance.
It's a use case for symphony work?
No. Well, not really, no. As you will see, the workflow one is mostly a state machine, so it uses the state pattern. Think of any software, I mean desktop software you use, like a word processor, for instance. So whenever you type something, and then you want to cancel what you typed, in fact, the software you are using is saving the intermediate steps into Memento, so that when you run Control-Z, it gets the previous Memento and resets the state so that you can see the changes. Okay, so it's basically useful for saving state or saving intermediate states and recover the previous state. So it used to be implemented first for softwares where you have a cancellation option or cancellation feature. All right. In the PHP world, there is one particular use case where you can implement this Memento pattern. Have you heard about event sourcing? Some of you? So event sourcing is a technique where you have a domain object, like, I don't know, an invoice, a reservation, or whatever entity object which has a life cycle. And you want to keep track of all the major changes of your entity or your domain object. So, for instance, you want to know when the entity has been, when the invoice has been issued, and then you want to know when the first payment has been collected, and you want to save this information, and then you want to know when the invoice has been closed or saved. So all the major changes in the life cycle of your object will be saved. And so with event sourcing, as you save those events that occur in the life cycle of your object, this gives you a natural audit log of your objects. And so basically, the domain events that you are going to save are basically sort of mementos. Okay? So a domain event is in fact a memento, because by replaying the list of events, you will be able to reconstitute the state of your aggregate or your domain object at any point in time. Maybe you want to replay the list of all events to know what's the actual state, the current state of my entity or my domain object. Or you just want to replay all the events that occur, let's say, before January 1st. And you want to know what was the status of this domain object on January 1st. So if I apply my previous UML diagram to something more concrete with event sourcing, we can imagine that the client code is some, let's say, invoice service, an object that allows you to manage your invoices. The object that we want to save state for is the invoice entity or invoice domain object. And so this one has some state, and this one will record the event when we will change the state of this invoice. So the invoice entity or invoice aggregate or invoice domain object, whatever you want to call it, will record domain event. So domain event is a memento. As you can see, the memento will have, it will save some state, some payload or some data. And then the caretaker, in this case, will be some invoice repository. So some object that is responsible for saving and retrieving an event stream. As you will see, it's a simplified version of event sourcing. So, from my domain model perspective, we have the invoice aggregates, and so on the first, the first state of this invoice will be determined by the very first event that will be recorded by this aggregate. So this aggregate will record a new, let's say, invoice issued event, which contains the ID of this invoice, the due date of this invoice, and the due amount. And then at some point, the client will pay for the invoice. So we will record another event, which is invoice paid, and we will just add the payload for this particular event. So just the data that are useful for this event. And then if I combine basically the two events, or if I replay the two events, I will be able to recalculate or recompute the actual state of this invoice object. Right? Does it make sense? Yeah. So from the PHP perspective, we have some invoice service, invoice repository, some event bus in between, and then from storage perspective, we have an event store. So this is the event store is where you will store all your events. So when you do event sourcing, the good thing is that you just stack all the events that happens in your domain object. So it's just a huge pile of events. And you can store your event store in Redis or MySQL or a file or whatever storage engine you want. Of course, storing a list of events serialized as JSON, for instance, that's usually the case. It's not very efficient for reading. So usually you have some projections that are triggered to recalculate some optimized view model when you want to query your model. So you can do event sourcing, but usually when you implement event sourcing, you also implement what we call CQRS, so command query responsibility segregation, if I remember. So basically, you will split your model in two parts: the write side and the view side. So the write side will be usually the event store if you use event sourcing plus CQRS, and on the query side, you will generate projections so that you will replay all the events and you will generate in separate tables or separate storage engine an optimized query model to get the actual state of your domain. So, for instance, this is how you can easily implement event sourcing with a very basic approach. Of course, you have more complex frameworks like Proof, for instance, which is dedicated for implementing event sourcing. But the most important is that your aggregate, this is what we call the aggregate. The domain object must have a unique identifier. It's an entity, so it must be uniquely identified. And usually, the identifier is a value object. Like in this case, it's an invoice ID object, which is basically behind the scenes a UID in this case. It's just a class to have a custom type. And as you can see, we have a recorded events list. So we are storing all the events. And that's pretty much it. I don't really need to store all the other informations like the due date, due amount at this time. If I don't need them, I will just store the recorded events and the ID. And so I have a getter to get the recorded events and get ID methods. And as you can see, there's this method, record that, which is private, which takes a domain event, an object that implements this abstract class or this interface. And I would just stack this new event. And then, yes, and my construct method has been made private. I don't really want to allow someone to instantiate this invoice class manually, because the very first operation, which is issuing an invoice, you don't really create an invoice, you issue an invoice. So this is why it's better to have a semantic construct method, so a static construct method like issue, which will execute the construct method, but it will also record the very first event, initiating the new life cycle of this object. So as you can see, I'm recording that this invoice has been issued. And inside the domain event, which is an object, I will store the payload, which is the invoice ID and the due date and the due amount. So we are recording the first event in this case. And at some point, we want to record a payment. So that's the new operation which will make the state of this object change. So I will check that in this case, so payment date must be null, because if the payment date is not null, that means we have already paid this invoice, so this is not a legal operation. And we want to make sure that the amount that was paid corresponds to the due amount. If it works, then we can record a new event. Now the invoice has been paid. So we will just store again, the aggregate ID. So we have to always pass the aggregate ID to the domain event so that we can match it to the corresponding aggregate. And then we will pass some payload information. In this case, I just want to know on which date this invoice has been paid. This is only the information that matters in this case. So the event just know that. And so my invoice need also some other methods to reconstitute the state. So remember that in the Memento pattern, in this case, the domain event acts as the Memento object. So if I want to restore the state of my invoice, I need some methods to reapply domain events and to reconstitute the state of my aggregate by getting information from domain events. So this is what this apply method does. The apply method is the equivalent of the restore from Memento methods you have seen in the generic UML diagram. So this method takes any domain event object, and then we will check the type of this class, the concrete type, and we will be able to reconstitute the state of the invoice based on the domain event we are going to receive. So if you have maybe 20 or 30 events that may occur for your entity, then you will have a huge switch case statement here, but that's centralized in this method. At least it's explicit. So apply so allows you to recalculate the state of your object. And as you can see, there's another method from event stream. So in this case, this is when you want to fetch a stream of events. Let's say you store your events in the database, and so you will refetch your list of events in chronological order. And we want to reconstitute an invoice object, so you will use this static method. So as you can see, I'm again instantiating the invoice with its ID, and then for each event in the stream, so in this case the stream object is an iterator. It's an iterator of domain events, and then I will simply reapply each event sequentially to reconstitute the state. And so with your repository, you can tell, I want to get all events for this aggregate ID, or I just want to get the events from the beginning to January 1st, and you will be able to reconstitute the state of this invoice as it was on January 1st. Make sense? Yeah. And then, so this is the caretaker object. So in this case, the repository, which is able to save and fetch the mementos or the domain events. So as you can see, when I want to save an invoice with my invoice repository object, I'm going to get all the new recorded events, because get recorded events only knows about the new events that you have recorded during the request. And then we will publish all the recorded events to an event bus. So the event bus just sends the domain events, and then you have listeners on the event bus to do things on events. So maybe you want to compute some projection whenever an event has occurred. So you will plug some listeners on your event bus to trigger some specific calculations. And usually at the end of your event bus, you may have some end of a transaction to persist everything to your database, for instance. And then we have the get method. So I want to retrieve an invoice object by its ID. So in this case, I want to fetch the full list of events, of domain events for this invoice ID, and I will reconstitute the invoice object by reapplying every single event on this invoice object. Right. So it's quite simple. And so this is, for instance, my invoice service or my client code. This is the code which uses everything. So this object is used in a controller, for instance, in a controller layer. So it's my domain service. So this service has access to the repository. And so at some point, someone in my accounting department wants to issue a new invoice. So the code will trigger this method, issue invoice, passing some context like the issue date, the currency, the amount, and so on. So we will issue a new invoice and save this new invoice and returns the invoice ID so that we can then redirect to the invoice. And then at some point, the customer will pay for this invoice, so we will record the payment. So we need to refetch the invoice. So this is why we are using the repository that will get all the events from the event store and regenerate the state of the invoice with the domain, with the event stream. And then we can record the payment. So in this case, it will record a new domain event. And we can save the new domain events to our event store. Okay, so every time I call a domain method on my aggregate, behind the scenes, we are recording a new series of domain events. Right. It's good. So we can try implementing it. I've worked on a skeleton because there's quite a lot of code to write. In the repository, I published this morning an experiment. It's something new. It was not planned at the beginning, but I had this idea yesterday night. So if you look at, there is a Memento branch on the Git repository. So I will merge it into the master branch. Memento. All right. So we are still on this web shop example. I introduced a new namespace called event sourcing, which basically provides some generic interfaces and classes for implementing event sourcing in a very simple way. So at least we need to identify an aggregate route. So aggregate route is your entity, the domain object that you want to consider the aggregate. And so as you can see, my aggregate route must have at least a unique identifier, and it must expose a method to return the list of recorded events. And I'm using an object instead of a simple array to store recorded events. Then we have some interface to identify an aggregate. So the aggregate identifier is an object. It will be a value object, which must expose maybe some toString method, because at some point we want to save this information somewhere in the database. And then we have an interface which describes a domain event. So a domain event so it must identify an aggregate because it corresponds to an aggregate. We have the aggregate ID. Of course, we have a timestamp because we want to know at what time this event occurred, and we want to have a payload, which is just a simple two-array representation because we want to store that payload into our storage engine. So we may want to JSON encode this payload at some point to store it. All right. And then we have the recorded events list. So this object is just a collection. So remember the object calisthenics I talked about yesterday? There was an object calisthenics saying that you should encapsulate or you should treat arrays or list as object, as collection objects. So this is what I'm doing here with this new class, recorded events. And so as you can see, this class takes an array of events. I'm checking that we only have instances of domain event interface in this array. We can't have something else. And then we have some useful methods on the collection to add new domain events or to get all domain events or to check if it's empty and so on. So it's easier to manipulate a collection object rather than a plain raw PHP array. Now, the shopping cart, so that's the new section, the new namespace. So I want to know the activity on the shopping cart. I want to know whenever someone's issue or initiate a new shopping cart session, I want to record the activity on this shopping cart. So whenever we add a new product and a new quantity to the shopping cart, I want to know when someone's empty the shopping cart or check out the shopping cart and so on. So the cart session object is the aggregate. So as you can see, we have a cart session aggregate, which implements the aggregate route interface. And this is where I will record the lifecycle events. So we have this private construct method, which just initialize a cart session with a cart session ID. We have this record that method, and I forgot something. And then we have, so the static method initiate. So you can initiate a new shopping cart session. So you can pass the identifier yourself if you want to specify your custom identifier. Otherwise, it will be generated. As you can see, I created a cart session ID class. And the cart session ID will be, in fact, the concatenation of the class namespace and the ID of this object. The reason why I'm using UIDs is that you can generate them upfront. So you always know before saving what's the unique identifier of your object. If you rely on auto-generated IDs in your, let's say, in your database engine, that means you won't be able to do this before saving your entity to your storage engine. So this is why you should use UIDs most of the time to uniquely identify your object. Just be aware that MySQL is not very efficient on UIDs, on very large record sets. So what I usually do when using MySQL is to have both. I have the regular MySQL auto-incremented IDs just as an internal identifier for MySQL to make relationships between my entities or my tables. And I have an extra custom UID for my domain part that I can completely deal with. So in the PHP code, I use UIDs, but for the storage point of view in MySQL for efficiency, I let MySQL use these primary auto-incremented IDs. If you use Postgres, then you can use UIDs with Postgres. It's native and it's optimized by default in Postgres. So as you can see, we want to record a new cart session with a session ID, and then we will record the very first event that we have initiated a new cart session. So some customer has opened a new basket. And then I want to record the activity. So at some point, the customer will add some product to the basket or to the shopping cart. So we have this add method, which takes the product and the quantity of this product reference. And so again, in this case, it's an event. So I'm going to record that a new product has been added to the shopping cart. So the event will take care of storing the aggregate identifier plus the payload. So in this case, the payload is the product SKU, the product unit price, and the quantity. This is the only information I need here. Notice that in event sourcing, the convention is to name the event with a past tense, because the event has occurred, so the event must be given in a past tense. So then you can continue the implementation, if you like, by creating new event classes, like we want to record that a product was removed from the basket, so you just pass the product SKU or the product object, and then you generate a new event. We want maybe to record that we saved the basket, because maybe the user wants to come back tomorrow and he wants to retrieve the basket with the items he puts in the basket. And at some point I want to record that the cart session has been emptied. Or maybe your basket will also expire at some point. So you could also have a method that forces it to expire, and you will trigger an event that the cart session has expired. So we record these events, and then we have a method to return the list of recorded events. As you can see, a domain event like cart session initiated is a very simple object. So it's a plain old PHP object. There's no particular logic in a domain event. It's just a data object. It stores information. So the constructor receives some parameters, like at least the aggregate identifier, the timestamp, which is null by default. The most important is that when you do event sourcing, you want your domain events to be very lightweight. And so this is why I'm reconverting the value objects back to scalar values, like the UID is converted back to a string. But if I request the aggregate identifier, as you can see, I'm recreating the cart session ID object from the scalar string I've stored in the object. So this way, by storing just scalar values in my domain events, it's easy to serialize or to expose somewhere if I want to send it to the database or something else. So we only store scalar values, but the getter method will always reconstitute value object for the domain. So this event doesn't generate any payload. It's an empty payload. We just initiated a new cart. And for this one, product added, we are storing more information about the payload. So as you can see, we are storing the product SKU, the unit price, the quantity. And so for the money, so I will decompute the money in two properties, two scalar properties, so the amount and the currency. But still, if I want to get the unit price, I will still reconstitute the money from the data, from the scalar value. So from the domain's perspective, you always deal with money objects. But for the storage point of view, we will just need to get scalar values to ease storage and serializations. And this is where my get payload method so returns just the useful information to be stored in my event store. So this is what happened when this event has been recorded. And so the cart session ID is just a value object. As you can see, so it's the aggregate identifier. It's made of two things. So a type and a UID, a unique UID. So for the type, I'm using this package. So class function, it's a package I got from Composer. So if you merge this Memento branch in your master branch, don't forget to run Composer update to fetch this package where we have this class function. It's a useful package which allows you to manipulate class names. So this method short basically gets the last part of a class namespace. So it trims the namespace on the fully qualified namespace and just keeps the end to make shorter names. So if my namespace is web summer camp / webshop / shopping cart / cart session, it will just get cart session to make a shorter name. So my UID or my unique identifier will be cart session _ the UID. So that I can store multiple types of aggregates in my event store. If I want to, let's say, store the status changes of my users. If a user is an aggregate, I will have user underscore the UID or invoice underscore UID. So in the database, it's easy to identify if this UID corresponds to an invoice or corresponds to a shopping cart session or whatever. And the toString method, as you can see, concatenates the type underscore the UID as a string. So we have this small implementation, and if you look at the test, this is what we have. So we create products, and then we initiate a new cart session. So remember that when you trigger this initiate method, the very first domain event is recorded. And then I want to add 3 products to my shopping cart, so it will generate 3 new domain events. And at some point, I will want to empty my shopping cart, so it will generate a last domain event. So in the end, I expect my shopping cart session to have recorded 5 domain events. All right? We can try. So it works. And if I print them, yep. So we can see all the domain events in chronological order. So cart session initiated, product added, product added, product added, and cart session emptied. Right. So for now, everything lives in memory, but at some point we want to store that maybe in an XML file or in a database. So we would need to create the repository layer so that we can store and reconstitute the state of this object. Does it make sense? All right. So let's build the or let's try to build the repository part. So first of all, we need an event bus and an event store. Just checking if we have time for that. The event store will get the events. Yeah, okay. So let's try to make this event store. So we want to make an event store. The event store is this is the object that will be responsible for serializing all the events. Don't know how I named it in my slide deck. The repository store git stream. So basically, the event store has to retrieve a stream of events. So based on an aggregate identifier. So this is why we have this interface aggregate identifier. So whenever you have different types of aggregates like users, invoices, shopping carts, and so on. So I want to retrieve an event stream, and this is going to return some, let's make it simple, some domain event object. Oh, well, not an array, sorry. It's an event stream. It's a domain event stream. Maybe we can just make it an array, as it's simpler. It's a class, it's not an interface. In this case, we can stick to a class, not need to have an interface. There is not a lot of chance that we have to make different implementations of an event store. And this is going to return some domain events, a list of domain events. And so we will not do the event bus part. In fact, having an event bus, the event bus is mostly useful when you want to listen to all the events and perform some specific calculus when any event is being dispatched or being published. We can just combine the bus and the store in the same object, in the same class. So in this case, we want to store a list of domain events. So in this case, it will be our recorded events that we want to store. All right. And let's say that we want to store that in maybe on the file system. Yes, let's make a file system store. So we want to store the list of events on the file system. So let's say that we have one directory for one aggregate. So a directory for one aggregate, and then each event can be a JSON file, for instance. For each event, we have a JSON file that just serializes the payload to JSON. All right, so store. Let's say, so I want to have an event store which store to this directory. All right. So I also want to make sure that the directory exists and it's a valid directory, and I want to also write to this directory, so we want to make sure that this is a writable directory. As you can see, this assertion library we have introduced yesterday is very convenient. If you had to do all the check yourself with the conditions, every time it's an if condition, so 3 lines of code for each condition you have to write. So it makes your code bigger, and you have to also test this code you write yourself. While this library is already well tested, you don't have to take care about. And making these safeguards yourself doesn't bring value to your project. So this is why it's better to rely on such library. So we have this store method. So we want to store that to the database, or to our database, which is a directory. We need to iterate over the recorded events as event. All right. Then like this. Remember the object calisthenics, we should have only one level of indentation per method. So we have 0 and then 1. So this is why I'm having this do save method or do store. So the domain event, we know that domain event has, it contains the aggregate ID, it contains the payload, and it contains some useful metadata like the timestamp. So what I want to achieve is to store that into the file system. So I need to compute the path. So it will be something like the directory, and then the directory of the aggregate, and then the JSON file, the event. Not %u. I don't know if we have to, we have to first create a directory if it doesn't exist. Aggregate store equals, so in fact I need this. So remember the aggregate identifier object has a toString method. Right, and then so the event store will be the aggregate store plus the event file name. So we have aggregate store path and the number like 1, 2, 3 and so on. Alright, and now we want to file put contents into this, and the data will be a JSON encode. Like this. Something like this, get timestamp. should have something like this that should work. All right. Okay, so that's my method which stores to the file system. So we compute the path to the JSON file where we want to store the event, the domain event. And as you can see, I will have two parts in the JSON file. I have a section which contains headers, so contextual information like the aggregate ID and the timestamp. And the second part, which is the real payload, the real value of this event. And I'm going to write this down to the file as a JSON. And we need the opposite function or the opposite method, which reads the file system, get all the JSON files, and get all the JSON files and reconstitute the domain event stream. We may have some issues with ordering, because if we after 10 the order of the files may be not correct. Maybe it would be safer to not use an integer like this one, but the timestamp. Let's try with the timestamp instead. Should be safer to format the timestamp as a Unix timestamp. The thing is, I don't know if we'll take microseconds, because if we'll see. Hopefully we'll have microseconds, so let's try with S. All right. So we have this, and then this one gets stream. So we basically want to find the directory for the aggregate. If the directory exists, that means we have recorded events. So we will read all the JSON files. Or maybe we could have simply stored in one file, one JSON file for all events. Maybe it's simpler. Yeah, let's do this. I don't need to have a directory plus dedicated JSON files. I'm sorry. It would be simpler to have just one file so that we just reach the file and then we just read the JSON file and have a list of domain events. All right, so and we don't have to take care about ordering and so on. So it will be aggregate here.json like this. Okay, so no need to create directories or subdirectories. And then we need to have come on. Yeah, we need to get data, so we have all right, and here is I don't know how to name this method, like normalize. So this goes somewhere over here. And normalize simply returns a two-array representation. Like this. initialize domain event that returns an array, and at the end we want to save that. So we have we don't know the domain event here. Aggregate ID. Come on. Okay, and now we have like this. And events. All right. It's just very straightforward. All right, so we iterate over the list of recorded events. It would be probably also better to have a get aggregate identifier method on the collection, because the recorded events are all related to the same aggregate ID. So as an improvement, we could change the recorded events class to have a method to return the aggregate identifier. And then I'm converting my domain event to an array, so an array of scalar values, so that it will be easier to serialize to JSON. And then at the end, the list of all events is serialized into a JSON file. So we have the directory / the aggregate identifier.json file. All right, so that's the simple aggregate or the simple event store. And the getStream method is straightforward. We need to read this path. So we'll check that assertion file this aggregate store path. So if it doesn't exist, then we have an exception. And then I will JSON decode or events. So for each event as event, and my stream oh yeah, this is where we forgot something. So we need to reconstitute a domain event object with the payload. So that means each domain event needs to expose some static method like from domain event or from payload, which also means we need to know the type or the class name of the event. So that's something we need to store also in the headers. So I need to store the concrete class of the domain event. All right. So event type, aggregate ID, and timestamp. And so here I can get the type. And we need to check that we have this static method. But I will assume that it exists. It will fail if it doesn't exist. So I want to execute a callback. So event type. The method is call user func array. So the class, the name will be, let's say, from payload, and then the list of arguments will be the event payload. And then I can return the stream, so I misspelled here. Hopefully it should work. I don't know if it will work, we'll see. As you can see, I'm assuming that the class, which is in event type, has a static method called from payload, which is going to receive the data, the array of the payload array, which includes headers and underscore payload. Make sense so far? Yeah? All right, so we have this very simple event store implementation, which is very straightforward, about 70 lines of code. And now we can check if we manage to store these events. So we can do this in the test file. All right. So we want first to try that we can store the recorded events. So there it is. So I want to create an event store. Let's say that I want to store in my TMP directory. All right. And then with the store, I want to store the recorded events. How do we remove files into a directory? How to remove a directory in PHP? There's a remove there? Huh? RM there? Just want to make sure that the test is already reset correctly. Yeah, thank you. /tmt. Okay. Yeah, in PHP units, this method setup allows you to run a piece of code before each test. So before every single test I write in this test suite, we will ensure that we want to remove the directory and recreate it so that we show that the database is always reset and we don't want to run the test against a previously set database. All right, so let's run the test. Well, I'm surprised it worked. So we have an event store directory, and we have card session underscore the uid.json. Looks good. What do we have in it? Yes, we have a list. We have a collection of events. As you can see, the event type: web summer camp, web shop, shopping cart, card session initiated, with the aggregate ID that is repeated every time, timestamp, the payload, and so on. So we managed to store our event stream, and so now we want to reconstitute the event stream. So if we want to reconstitute the stream, like, let's say I want to recreate the same session object, a new session. So that means we must have a card session, so the card session class. And here, remember we had this initiate method, but for this one we need to do it from an event stream. And so the event stream will be fetched from the store. So get stream, and we need the card session ID. So I will just store it in a and I will be able to compare that the two session objects, the previous one and the new one that is reconstituted are equal, which means they should have the same. Oh no, it doesn't work because one contains recorded events, the other one will not contain recorded events. So session ID here, so I want to get the stream for this card session ID. So we need to implement this from event stream method, and our domain event classes must also implement this from payload static method. And so this should recreate a new session object. So we are almost done. So my card session class needs a public static function method from event stream. Oh, and we need to pass the session ID. So the stream is a collection of domain events. All right. So first of all, so we want to instantiate the card session. So I will just instantiate myself with the ID. And I will simply for each over the list of domain events, and I will ask the session to apply. So again, we need this method, apply the domain event. And in the end, I want to return the reconstituted session objects. And so apply simply it simply has a huge switch case. And let's say, so case event is an instance of so card session initiated event. So maybe you want to do something with this event. So for instance, let's say that we want to store some state here. You want to reconstitute the state, like private initiated, which is false by default. All right. Then if this event has been raised, that means you want to set it to true because you... And maybe you want to know if the event was emptied, like instance of, or maybe you want to reconstitute the content of the basket, like you have private and then a content array. You want to reconstitute the content of the basket of the card session. Then we know that whenever the product added event is raised, so product added, then we want to store this information into the basket, like content, and then I want to have the product SKU as the key, and then I want to store. You can see it's really up to you to manage the way you want to store the state of, or you want to reconstitute the state of your domain object, like quantity. So the event object contains the useful information like the quantity and the price. Right, and so on. So then you continue with the other events. All right, so this is how I can reconstitute the internal state of this domain object. I'm just reapplying each domain event, and I know that each domain event carries some information. So we have some useful values. And this is the second part of the Memento pattern. Applying is done without breaking encapsulation. This is where we say that it's done without breaking encapsulation, because each event is the memento, and so we restore the state from mementos. And so we just have one single method which allows us to restore the state of the object. I will just okay. I will quickly implement this method from payload public static function from payload. So we said that we have an array which in fact should be some sort of objects. It would be better to use an object than an array. Payload, and which returns an instance of itself. So I want to return new static or new self. New self is enough because the class should not be overridden. And so we need the aggregate identifier. So in our case, it's a card session ID from string. And we know that this information is stored at payload underscore headers underscore aggregate ID. There it is. And then we have the timestamp, so which must be a datetime immutable that I want to recreate from a format. And we said that we stored the format using the atom format, and we can find this information under payload underscore headers and then timestamp. So you just then duplicate this method in all the events, and you readapt the code to recreate the content of your event object. It's a very straightforward method. It's not super fancy, but it should do the trick. So we have from payload here. And in product added, so in this product added event class, so we have from payload, and in this case we need to pass the aggregate identifier, the product SKU, so we have UID from string, and we know this information under payload underscore payload or body underscore payload, and then underscore, or this one, SKU. All right, and then we have the money. So we have underscore payload and unit price. And here, currency. And then we have the quantity, payload underscore payload, and then quantity, and then the timestamp. And again, as we are always re-executing the construct method, we ensure that the state of the event itself is also consistent, because we are also re-executing the safeguards. So with this simple exercise, we have implemented a lightweight event sourcing system. Of course, it's not in this case usable in production. It's experimental. But it gives you the idea of how to use event sourcing in a project, and so how to use the Memento design pattern in the context of event sourcing. I still miss one, which was cart empty. So cart session emptied. So we have from payload, new self, and we want to have the session ID and the timestamp. Right, I think it's time for the coffee break, and we'll just need to run the tests after the break, and hopefully we should have it running. So we managed to store or persist our event stream. And now we manage to reconstitute an object state from a stream. All right, so we almost done this event sourcing system. So as I explained, so this is a very straightforward implementation of event sourcing. It's an experiment. I haven't done any event sourcing in production myself. On paper, event sourcing is great because you have a native audit log. You get all the data, you collect all the data you need for your business. Like for instance, if you want to know at some point how many users have put these particular items in their shopping cart between January 1st and May 31st, for instance, then you can generate a projection of this information just by iterating over your event stream and get all the product added events and check if the product added event have this particular product ID, for instance. So event sourcing allows you to get all of these data that really matter for your business. However, it's great on paper, but it's super hard to implement in real life projects. You need to be experimented first with object-oriented design, design pattern, domain-driven design, and stuff like that. And also because event sourcing, once you are live with event sourcing, you will face many other challenges, like asynchronous system. Usually you need to make asynchronous system because when you store your event in your event stream, which is usually one big table in your database, as you store the data in JSON, you don't want to query that big table. You want to generate projections of your data. So you need to have some asynchronous processes or workers which then optimize your query side, your query model or your view model whenever new events are pushed to your event store. Also, you will face problems like what happens if once you are live, at some point you need to introduce new events in your system, or if you need to deprecate an event. So these are all the problems you may face, and it's not very easy to tackle once you are live and you have collected millions of events in your database. Remember that in event sourcing, a domain event is an immutable object, as you've seen. Our event classes don't have any setter method. We just set the data in the construct method, and then we just expose getter method. Because we consider in event sourcing that whenever an event has occurred, it's done, it's frozen, so it's immutable, and when it's stored in the database or in the event store, you can't change your event store. You will also face the challenges with GDPR, because as you are storing all the data in an immutable way, whenever someone wants to anonymize this data, how do you face it? Because you can't change an event store, it's immutable, but so you have the data, but some clients wants to anonymize their account or destroy their account. So these are also all the problems that face with an event sourcing. So this is why I haven't used it myself in production. I'm just doing I did some experiments, very simple experiment like this one. Yeah, because it's great on paper, but lots of challenges in real production systems. So beware of that. However, you can still use CQRS, so common query responsibility segregation principle, where you will simply dissociate the common side, so the write side, from the query side or the view side. So you can do CQRS without event sourcing, but you can't do event sourcing without CQRS. And so you have libraries like Tacticians. So in PHP, Tactician is a library that provides a command bus. So it implements the command pattern and command handler pattern. And so you can dispatch commands, or a command is just an object that will be handled by a command handler, and the command handler is responsible for writing to your write side. So it does the writing part of in the CQRS model. And then you will create some workers or async processes to get data from your write side, let's say your database, where you have, let's say, hundreds of tables, and then you will then recalculate, optimize views or tables or documents in Redis or MongoDB or Elasticsearch or whatever other engine. So that in your application, whenever you want to query some information for rendering information, you will not query your write side, but you will query your optimized view model, like Elasticsearch or Redis, whatever. So you should probably look at CQRS for your projects, to use CQRS, and keep an eye on event sourcing just as for the philosophy of the system, but I don't recommend to use it in production without a lot of experience and on very big, complex application as a first experiment, because you will fail your first experiment with event sourcing. There are too many challenges to take care of. All right, so we just want to make sure that this works. Hopefully it will. So back to the test. Do you have any questions so far? I forgot to ask, but no? Okay, good. So from event stream, okay, so we need the session ID here. And I will just expose these attributes publicly just for simplifying the test. Of course, this breaks encapsulation, so this is not something we should do. This is just for the test purpose. So we want to check that initiated will have been changed to true, and the content contains the product information. So content should not be empty. So in my test, remember we are in the test. We are adding products, so we are changing the state of the shopping cart session. At some point, then we store this to the event store. So of course, this event store should be injected into a repository object. In this case, we are directly using the event store, but you don't manipulate the event store directly. You usually have some repository layer which encapsulates it. So in our case, it would be a cart session repository which takes the event store. What's next? Oh yes, we forgot something important. I just remember in the session, in cart session, whenever we record a new event, we also want to apply that event because we want maybe to also update the state, the internal state. So I forgot to add this because at the beginning we didn't have this apply method. So we record the domain event, and also we want to apply the domain event because we want to update the state for the actual in-memory representation of this entity or this aggregate. Don't forget to reapply the domain event. All right. So we want to check that assert true, that the new session has been initiated, and I want to assert, let's say, array as key for new session content. So I should have, let's say, this product SKU in the content array. So if we didn't make anything wrong, we should see that the state of this object has been updated or recalculated by replaying the list of events. If you want to have, or if you want to use event sourcing in a project, I recommend to use it only in parts of your application where you have lots of business expectation, where you want to have some native audit logs, where you want to gather business data, but don't do event sourcing on cruddish application where you don't need to get this information. It's not valuable. And sometimes it's better to make a CRUD application well than a wrong implementation of event sourcing.
There will be an error.
Okay. Oops, not yet. Cannot use object of type std class as array. Oh, of course, because JSON, we forgot to mention that we want to get the JSON as a PHP array, not as an std class object. When we JSON decode, we need to specify true here as a second argument.
And another one, in event you have to first, in the call user function array, you need to add the headers before event type, because event type is a...
Oh yes, true. Good catch, yeah. Yeah, that's true. All right. Yeah, thank you. So it works. So we have implemented event sourcing in, an experiment of event sourcing in half a day, less than half a day. So that's a custom-made event sourcing implementation. If you want to go deeper in this concept, you have libraries like Broadway or Proof in PHP. Marco Pivetta, who is at the conference, is one of the big fan of Proof. He did a lot of workshops on event sourcing, so if you have any questions, it's better to ask him at the conference. He will give you some useful information, I guess. All right, so I can... So we have... All right, it's in a repository. Good. State. So we have another pattern called state. So this design pattern called state allows to alter the behavior of an object whenever its state changes. Basically, when you have an object which has a life cycle, which is usually a finite life cycle, you can configure it using a state design pattern. It's useful for finite state machines. If you want to implement a finite state machine, like for instance, you have a traffic light. A traffic light goes from red, then from red to orange, and then orange to green, and from green to red. This could be implemented as a state pattern because it's something that is it's a cycle, life cycle, and you can repeat it. And you want to make sure that you can't go from red to green without first going from red to orange and then orange to green. So the state pattern will ensure that you do not move from one state to another without making the transition in between. If you, tomorrow there is a workshop from Tobias Nilholm. He's going to talk about how to implement state machines in PHP using the Symfony workflow component. And so Symfony workflow component is one of the components in Symfony that implements the state pattern. So this is just a very short introduction of state patterns, and you will go deeper with Tobias on state machines. So this is useful patterns for state machines and workflows. You want to isolate object states into objects. So the state will not just be some string, but it will be an object. And so it will also prevent the code from having too many conditions when you have when you have complex workflows or complex state machines. This is a very simple example. It's not a real-world example. I mean, it's not something you can find in a project, but it's for an education purpose. I took this example from Sebastian Bormann repository, the creator of PHP Unit, where he takes the very simple example of a door system. And so when you have a door, the door can be in different position or different state. The door can be open, the door can be closed, and the door can be locked. And so, of course, if the door is locked, you can't open the door. You first unlock the door, and then when the door is unlocked, that means it's closed but unlocked, and then you can open the door. And you want to make sure that you can't transition from a state to another without in an invalid transition. You want to make sure that transitions are always done in a coherent way. So to do that, you need to create a state transition matrix to identify all the states of your object or of your state machine. And then the transitions will be the method allowing you from going from one state to another. Like if I want to go from open to open, then it's invalid because we are already open. But for the door, I want to go from the open state to the closed state. So for that, I will use my close method. So close method will transition from open to close. But I can't go from open to locked. Doesn't make sense. It's an illegal transition. Then from the closed state, I want to reopen the door. So I will use my open method to transition from closed to open state. But it doesn't make sense to go from closed to closed. And from closed, I also want to lock the door. So we have a lock method which transition from closed state to locked state. And then from locked state, I can't go from locked state to open state directly. I first need to unlock the door, which means I will transition from locked to closed. And I can't go from locked to locked, as we are already locked. Okay, so that's my transition state machine matrix. So now I need to represent those three states into objects, as classes, as objects. And the transitions will be methods. That means the three states will have the four methods, and some will be implemented, and some other will just throw exceptions, preventing you from doing an illegal operation. Right. Make sense so far? Yeah? So let's say we have our door object, and so my door object has an initial state of open. All right? In this case, I'm not still using the state pattern in this example, as you will see. So let's say we have open state, and then I want to close, and I want to lock, I want to unlock, and reopen. If I do it without the state implementation, I will end up doing lots of conditions. In this case, we just have very small condition or simple conditions because we just have one state value. But sometimes your state is a combination of multiple attributes or multiple attribute values. As you can see, the door class has method like close, open, and then we check that what is the actual state of this door, and are we able to perform a transition to another state. If it's okay, then we change the state, otherwise we have some exceptions. So we could just keep with that because it's a very simple example, but when you have very complex states where the state is defined by multiple values, then it becomes very complex because you may end up with lots of conditions for checking each actual state. And sometimes you have state machines where you can go from one state and you can go to multiple transition and go back. So it becomes just a mess to maintain. Right. So instead, we are going to extract the state into objects. So we need to raise some interface, like a door state. And this is where you will have all the methods from your matrix, from the state machine matrix. Right? So this is why it's very important to clearly define what is your state machine matrix to identify all the methods you will need to implement in your generic interface. So any door state must have an open method, close method, lock method, and unlock method. And each of them will return an object. It will return the next state, the next door state. Okay? So they either throw an exception or they return the next valid state. You can start with an abstract implementation, which just implements all the method with only exceptions everywhere. So as you can see, we have abstract door state. And for now, I will consider that close generates an invalid door state operation. So it's my exception, my custom exception class. And again, I'm using static or semantic construct method to give more meaning to my exceptions, right? So for now, my four methods they prevent me from doing anything. And now each concrete state class will extend this class and will just override the methods that are allowed in the matrix, right? So like for the open door state, we know that according to the matrix, we can only go from open to close. So I will just override the close method. And so I can go from open door state to closed door state. And then from the closed door state, when the door is closed, we can reopen the door or we can lock the door. So we just override those two methods. And then from the locked door state, I can only unlock the door to go back to a closed door state. Right, makes sense? So in the end, my door object, the main class, will have its own state. So you have the door state, but you could have also other properties that are specific to the door itself, which is not dedicated to the state. like maybe the door color doesn't depend on its state. It's just some attributes. So you could have a private color information. It doesn't change anything for the state itself. We only encapsulate the state in an object whenever we have transitions. And so, as you can see, my door class also has the form method, close, open, lock, unlock, which delegates to the state object. And we are skipping all the conditions, making the code much easier to test, because there is only one path of execution. There is no condition, so unit testing this class will be much, much easier. So if I want to close the door, I will ask the state to close the door, and if it's a legal operation, I will store a closed door state. Otherwise, we'll get an exception. It will be an illegal operation, and I won't have my door object in an invalid state. Okay, so super simple. And then you can have getter method or either method to check the state of your door, just by checking the type of state object you are storing in your door object. All right. So there's my door. It's by default it's open. That's my initial state, and then I can close, lock, unlock, open. So this workflow works. But if I now try to open between lock and unlock, then I will get an illegal door state operation. All right. So in Symfony, we have this workflow component which allows you to describe state machine. They don't exactly force you to extract state in separate classes, because that's the complexity of the pattern. You have to create many classes, a new class for each state. But with Symfony, the state machine component just allows you to describe the states as a YAML file or a configuration file. And you just need to expose some setter method in your entity so that the state machine can just set the new state. But you can, with Symfony, you can make some complex workflows like this one, where you have your initial state, and then you can transition from start to Travis using this submit transition. So square is a transition, and the circles are the states. And as you can see, when Travis runs, it then runs some updates. It runs an update. And when the update goes back to the Travis state, then we have Travis wait for review. So we have this transition, and then the pull request. So it describes the pull request status or state machine. So the pull request now is in review state, so it has to be reviewed by people, and then maybe some people on GitHub will ask for adding changes. So we will request some changes to the pull request. So again, we have to recode and then re-update Travis, run and test again. Or maybe the review is accepted, so then we can merge the pull request. Or otherwise, the maintainers will reject this pull request, and then pull request will be closed. And when the pull request is closed, it might be reopened at some point. Okay? So you can describe this state machine, this complex state machine, using Symfony with a YAML description file. So you can see in red, we specify that it's a state machine behavior, because by default it's a workflow, and the workflow command has been also tweaked to implement state machine pattern. So in this case, we are configuring a state machine. We specify which class, or which entity object, or which domain object we want to manage through the state machine. These are the states in green, and we have the transition in purple, transitioning from one state to another. Right. And so the state machine component, or the workflow component, will manage that you always transition from one valid state to another. So you have a workflow service, and you have some twig helpers in Symfony to do that. So this is something Tobias will talk about tomorrow in his workshop. Okay, so let's move on strategy. I think we will we will be able to implement this one based on what we've done with the event sourcing. I think strategy is the most famous one and the most simplest one because it's just a matter of implementing interfaces, basically. Whenever you have an interface and you have multiple implementation of the interface, then you usually have some sort of strategy. It just depends on how you use it. So the strategy pattern allows you to change the behavior of an object at runtime. So basically, a strategy encapsulates algorithms of the same family, of the same nature, in separate classes. And instead, we expose an interface, and then you will rely on the interface. And the code, your client code will just be, the client code will rely on the interface, and then you will inject the implementation you need. So it's just a matter of switching algorithm of the same nature, of the same family at runtime. Right. So whenever you have different algorithm which performs the same type of operation, but with different steps, for instance, you will encapsulate them into a strategy. So you will just expose an interface, and then you will have separate implementations of this interface. So one algorithm in one class, and they all implement the same interface. It's no more than that. The goal is to avoid the conditional blocks in your code, like the if condition or switch conditions blotting your code. Instead, you just want to inject the right strategy or choose the right strategy at runtime, depending on some state or some value. So this is my client code, which depends on a context. So the context will perform some operation, and the context needs a strategy to perform this operation. So as you can see, the context uses, at some point, a strategy. And strategy is just an interface. So this method operation, at some point, calls this algorithm method. And then you may want to have different strategy, and you will inject the strategy you need into your context object, depending on the situation, like depending on your environment, whether I'm in production environment or in dev environment, or whether I want to make a sort from A to Z or a sort from Z to B. This will be two different implementation of a sort strategy, for instance. So that's an example where you have, let's say, an array collection, and your array collection exposes a sort method. You want to sort your collection. But the way you will sort the collection will depend on a sorting algorithm. So you will be given a type, and in fact the type will allow you to select the right sorting strategy. So it can be a bubble sort or heap sort or quick sort or natural sort, whatever. So depending on the type of collection, you want to maybe to choose the most optimized sorting algorithm for sorting your collection. So each sort algorithm will be encapsulated into a dedicated class, and all of these classes implement the same interface. That's just it. So strategy can be found in everywhere in code bases or frameworks. As long as you have interfaces, it should be easy to identify a strategy pattern implementation. This is just an example, let's say, in the Symfony framework, where we have this system where you can render sub-fragments. I don't know if you already played with HSide includes, for instance, if you have Varnish. So you can render small fragments in your HTML pages, and these small fragments will in fact be HTTP request to the server, and which will generate just a very small piece. And this small piece of HTML code can be cached by a reverse proxy cache like Varnish. So in Symfony, we can decide to generate ESI or to generate server-side includes if your web server supports server-side includes. Or we can also decide to ask Symfony to generate some tags for h-include. So like h-include is like ESIs, but on the front-end side. So it's managed with Ajax request with a JavaScript piece of code. So rendering this small string, an ESI tag or an h-include tag or an SSI tags can be defined using a strategy. So we have this interface, the fragment renderer interface, that renders a fragment based on some parameters. And as you can see, the fragment handler receives the renderer you want to use. So this renderer is a string, and these strings maps to one of the strategies that are stored in the list of renderers. So it's just a key of one of the renderers. So if I want to render an ESI tag, for instance, with my fragment handler, I will use render URI, and then I will pass the string like ESI. And so this function will fetch the right strategy algorithm using this key, and it will delegate to the render method of the strategy. Or if I want to render an h-include tag, then I will pass h-include here. That will fetch the h-include key, and which will use this object to render the h-include tag. So this is basically how it looks like in Symfony. We have this interface with just two methods. And this one is the default one, inline fragment render. This is when we do what we call sub-request. So it's an internal sub-request. So it's basically handling a sub-request and getting the response and cache the response in the buffer. If we want to render h-include tags, then instead we will render this syntax, which is an h-include tag that will be then rendered by the h-include JavaScript library on the front-end side. So of course you have to embed the JavaScript code that converts these tags. Or we have the ESI renderer, which generates an ESI tag. I don't know where it is. Well, it's a tag like ESI :include and then the SRC attributes and so on. So that's a difference. These are different strategies for rendering fragment elements in Symfony. And so the main object in Symfony is the fragment handler. And fragment handler has access to the list of renderers. So we have a stack of renderers. And as you can see, when you want to render a tag like an ESI or h-include or inline tag, we are just finding the renderer by the key, and then we are delegating to the render method of this particular strategy. Super simple. So fragment handler is configured with a number of renderers, and so these renderers objects are injected depending on some configuration, because let's say in Symfony you don't want to activate ESI support. If you don't activate ESI support, this object will not be created and it will not be injected into the fragment handler. Yeah. So it's a very simple design pattern that allows you to extract each algorithm in a separate class and expose an interface instead. So in terms of thread principle, it fulfills the single responsibility principle because each unique algorithm is encapsulated, so single responsibility. Open-close principle because you can easily extend your client code just by injecting new strategies, new implementation of the strategy interface. But you don't change the existing strategies, you just create new one. And it also fulfills the dependency inversion principle, as you will type int against the strategy interface instead of type inting against the concrete classes. Right. And you can also easily combine it with other patterns, like the strategy can be also encapsulated as a composite. Like for instance, we could imagine having a chain fragment renderer object, which implements the interface and it wraps the collection of renderers that it will try one after the other, for instance. So you can combine strategy and composite, for instance. That works well. There is an example we can achieve in what we did. Can you guess where? in our event sourcing system, how can we extract some code and isolate some code? The answer is mostly here. This is a storage engine. As you can see, our event store only stores events to the file system, which is great for testing, in our case. But in a regular environment, you want to store your event in a database, and you want to have a transaction to store your new events to the database. So I want to make my event store object independent from the storage engine I want to use. Okay, whether it's a file system for test environment or whether it's a database storage engine for my production live environment. So what we need is to simply extract the storage part of this object. So we can, in fact, if we think about the single responsibility principle, we have two responsibilities in this class. Remember, if a class has two reasons to change, that means that it has at least two responsibilities. And in fact, the second reason to change is that I want to adapt the storage engine depending on my environment. Okay. So the storage part, the persistence layer, is a dedicated responsibility. So what we need to achieve is to depend on a strategy, which will be a storage strategy. And then we will have a file system storage, or an in-memory storage, or a database storage, or MySQL storage, Elasticsearch storage, and so on. And so you will be able to inject the right storage strategy depending on the context, depending on your configuration. From your event store point of view, it's the same. You always use this store method, this normal and this getStream method, and the store will delegate to the injected storage strategy. So we will simply just extract the file system code into a dedicated class, and we'll be done. So we have event store. So we need an interface. That would be the strategy, which is, let's say, event storage. So this method will have a store method, let's say, which takes the array of events. So the normalized array of events we want to store. So it's just a plain array of data. And we maybe have also a fetch, which will take some aggregate identifier. And it's going to return an array of data. Let's try. All right. That's just the interface. That's the strategy. And I will adapt the strategy depending on the context. So we now have a file system store. So I will just create a new class called file system event storage. So that's my first concrete strategy. File system event storage that implements my event storage interface. And we will just simply move the code. We will simply move the code to this class. So the code from event store will be moved to this class. It's just a refactoring. And so I need to move. So basically this construct method goes to the file system event storage. All right, so private directory with the assertions. So directory is a file system concept. And instead, in my event store class, so we will have a private storage attributes, and we will define the strategy, the storage strategy, which is the event storage interface. So this is the persistence layer. So I want to inject my event persistence layer or event storage. And then I will simply move this part of the algorithm to the storage engine. So all the file system dedicated function now can be moved to file system storage. So in store here we have this. Store, we forgot to pass the ID in the store methods. We need to pass the aggregate identifier as well. And then it's up to you to use it or not use it, depending on the situation. So we have the aggregate identifier. Yep, that's it. So my file system store just does that. So I can refactor event store here. After the for each statement, I will simply delegate to the storage and store for this aggregate ID. I want to store this list of events. I don't know how it is done. Maybe it's in MySQL, maybe it's in Redis, maybe it's in Elasticsearch. I don't care at this, in this object. It's just delegated. And just the fetching. So fetching will be this one. So basically, I will do that. So this part, just reading the JSON file and JSON decoding the JSON file, will be in my fetch implementation. So as I said, returning arrays is not really a good idea. We should return some collection of objects, because as you can see in event store class, we have some implementation details. That means all event stores that we will implement will must have an underscore headers section. So that's not a good idea. This is why we should have objects, so that we can get rid of these particular details of storing it. So here we have the fetch statement. So we are fetching the JSON file, and I will simply return JSON decode. And then we need to refactor event store. So we have here from the storage, I want to fetch for this identifier, I want to get the stored event stream. And that's it. As you can see, my event store class is just about 50 lines of code. Same for the file system event storage is about 30 lines of code. So these objects are very simple. The interfaces are lightweight. We just have just 2 or 3 methods per interface. So for now, we always fulfill single responsibility principle, open close principle, interface segregation principle, and dependency inversion principle. So we are all solid compliant with the code we wrote so far. All right, so we have it, and we can now refactor the test because we've changed the prototype. So card session test. So now event store and new file system event storage. So running the test should work again. Yeah, it works. So the refactoring is correct. We didn't break anything while refactoring the code. Can you go further in file system event storage? Can you identify other responsibilities in this class? Yes, for instance, defining the name could be a responsibility as itself. Maybe you want to have different strategies for naming your files. So that's a good point. So the naming strategy, the naming strategy could be an injected strategy. You could have a naming strategy object that is injected into your file system object, because you may want to choose how you want to name the files. Maybe you want to name according to the days, or maybe according to the UID, whatever. Okay, so that's a strategy. So we could raise a naming strategy interface, right? Another one? Encoding. Yes, encoding, decoding. In this case, we chose JSON, but maybe you want to store in plain text, or maybe you want to store in XML file. Okay, it's still file system storage. So from the file system class, you may want to create a JSON file system storage, XML file system storage, but you will duplicate all the file put contents and file get contents statement will be duplicated. So maybe instead you would want to encapsulate JSON encode and JSON decode statement into a decoding strategy or encoding strategy, and you will inject an encoder strategy into your file system object, so that you can swap from JSON to XML or to whatever encoding or decoding system. And so this way, you will have a very tiny class which has very small responsibilities, and the 2 other responsibilities, like naming and encoding, decoding, will be performed in separate strategies. Right? So that's an exercise you can achieve by yourself. As you can see, the test is also, in this case, quite complex because we rely on the file system, which means we have to tidy the file system whenever we have a test run, which is not very convenient because we depend on this file system. And there is nothing that proves there is a /tmp directory on my machine. If I run the test on Windows, there's a lot of chances that this test will fail because /tmp is not something you can find on a Windows machine by default. So maybe for running tests, it would be better to have an in-memory storage. So that could be another strategy where we have, let's say, in-memory event storage class. That's a new strategy, a new implementation. That will be super simple. But this way, I will be able to really simplify my test suite, making it much faster to run because I will not rely on IOs. I will just have in-memory operations. So I want to implement event storage interface. All right, so it's still the same. So I have my list of events, which is an array. And so I will simply store the events, and I will key all the events on the aggregate ID, so it will be easy to fetch only the event stream for one particular aggregate identifier. So let's say we have these events to string. Okay, it's because we may have some already pushed. Okay, just this stream equals. So I will get maybe. Oh, we need to. Yeah. It will be ugly, but I will just first fetch, and I will merge. So stream equals array merge. This with this one. It's just an ugly implementation, but just for the test environment, so it doesn't matter. It's in-memory operation. And fetch. So I'm trying to return the event stream or an empty event stream. If there's no event stream. It's up to you to generate an exception. If there is no event stream for this identifier, maybe it's better to have an exception. Just depends on what you define in the contract of your interface. So you can consider that no event stream means there is no aggregate. Because having an aggregate means at least we have one raised event. So it's up to you to decide whether you want to return an empty array or to raise an exception if this aggregate doesn't have any recorded events. So that's my in-memory strategy. Just that. So now I can refactor my my card session test class to rely on an in-memory system rather than depending on the file system. And hopefully we should have the exact same behavior in the end. So let's try. So I need to get rid of this setup method. I don't need to rely on the file system anymore. And instead of using a file system, I want to use, so I would just keep it for documentation. And so instead, I want to rely on an in-memory event storage. And it works. And so we no longer depend on the file system. So no need to clear the file system after each run. We don't need to bother of Windows or Mac OS or Linux file systems or specifications. So that's how you can raise or you can leverage the strategy patterns in your project. Just encapsulate the pieces that may change into dedicated class and raise interfaces or raise abstraction so that you rely on abstraction instead of implementations. Right? But okay, 15 minutes left. Let's go on. Yeah, these ones. Template methods. This one is super simple as well, as you will see. So template method is basically having a method which ensures that you always execute some sort of algorithm in a particular order. And you want just to allow the subclasses to override some parts of the algorithm, but you want the main algorithm to always run the same way, in the same order, right? So do you know how you can already secure a method to run always the same way and not being altered by subclasses? Yeah, final. So it's basically using the final keyword in this design pattern. All right. So the template method patterns lets you define the skeleton of an algorithm or a whole algorithm, and we want to allow subclasses to just override or change some part of the algorithms, not the whole algorithm, but just some steps of it, because you want to slightly adapt one of the steps depending on the context, right? It's useful, let's say I have an example where you are at the airport, for instance, or you want to check in for a flight. And the check-in process is basically always the same. You need to match your booking ID, your booking reference number with the airline booking system. And then the system will check that you are eligible for check-in because the check-in is open. And then you will want to fill in your passport number and then choose your seat and then check in your luggage, and then you are done, you can print your boarding pass, okay? So that's the process of checking someone on a flight. So all the steps like, so filling the information, choosing the seats, and checking baggage, and then printing the boarding pass are all the steps that are part of the whole check-in process. Right? So as an airline, I want to maybe offer a different way of checking. I can check in at the desk, but I can also check in online. Right? So we have different ways. So if I check in online, by default, the airline will auto-assign a seat, for instance. Okay. But if I check in at the desk, the agent will pick a seat on the plane. So you may want to have a check-in class with all the steps, and the steps will be implemented as a protected method. And then you will have subclasses like online check-in or desk check-in, and those classes will just override the protected methods to just change the steps of this whole checking process. So that's basically what template method does. So encapsulating an algorithm and preventing it from being overridden by subclasses, because you always want that this algorithm runs this particular way. But you want to let subclasses override some step of it. This is what we call the Hollywood principles. Hollywood principles means don't call us, we will call you. We'll call you back. Right. So basically you want to keep control, you want the main class, the parent class, to keep control of the whole process. The parent class, which has the final method, will be responsible for executing or calling the methods. So basically it's like the main class, the parent class, will be responsible for calling the children, basically. So this is how it looks like. You have the base class, which can be a concrete or abstract class. It's up to you, depending on the context. And the most important is that this is the template method. So it's just a final public method, nothing more than that. And this method, at some point, will call these methods, the steps. First step, second step, third step. And so these methods are protected. They might be implemented, they might be not, again, depending on the context. And you want your concrete subclasses to override those methods, to slightly change the way the whole process is being done. Okay? It's like adjusting a recipe, basically. Maybe if you want to make pancake, you will probably have to do you have some very specific order of the step to make pancakes. But maybe some cook will decide to add some extra, extra honey in the pancake recipe. And the other one maybe will bake it for with a higher temperature, let's say, right? But the whole process is that from the ingredients to the end, I have a pancake that is ready to be eaten. So this is how it looks like. You have your base class, which exposes a method, and you have the steps in between. Right? So that's the Hollywood principle. Don't call us, we'll call you back. This is an example from the Doctrine library that I found. As you know, Doctrine is an abstraction layer for databases. And as you know, the SQL language, which is supposed to be standard, is not in fact standard because each database engine has its own version of the SQL language with its own set of keywords. And like, for instance, when you want to paginate a SQL query, you won't find the limit keyword in Oracle or SQL Server. The limit keyword is very specific to MySQL, Postgres, and SQLite. So to allow to paginate a SQL query, Doctrine uses this template method pattern. In Doctrine code, you will find this class called abstract platform, which represents your engine, like MySQL, Postgres, Oracle, whatever. And there is this method, the modify limit query method, which is the template method. This is the final public method, which modifies a SQL query to happen the piece of code to paginate. But as this part is not standard, then we need to provide some way so that concrete platform can correctly happen their keyword at the end of the SQL query to paginate. So the MySQL platform will basically, in this method, do modify limit query. This method will basically happen limit with the index. And Oracle and SQL Server will have their own keywords to be appended at the end of the query. But the beginning of the query with select and all the fields and whatever, this is something generic or standard. So it's primarily done here in modify limit query. All right. So that's the abstract class, abstract platform, which has this modify limit query method. As you can see, it's the template method. It's a final and public. And then it delegates at some point to protected methods. Some are implemented, some are not. Like for instance, this one is pre-implemented. We consider that by default, the platform supports the offset keyword because most of them do. And this one is the very important piece of the algorithm that must be implemented by the concrete platform. So this is what this modify limit query method does. As you can see, there's a piece of code, and at some point at the very end, we have, well, it delegates to this protected method and this protected method. So these are the steps we are allowed to override in the child classes. But at least we always want this algorithm to run this particular way. So on MySQL, it's fairly simple. The MySQL platform class does this algorithm. So it receives the query to modify, the limit and the offset. And depending on the values, it happens just limit or limit plus offset. And as you can see, there's these strange things. If there is no limit, then it forces a very huge limit, which is the highest limit you can have on MySQL. Right. So you can, when you instantiate the MySQL platform and then you try to modify a query by appending the limit and offsets using the parameters, then it generates the corresponding paginated query syntax. Now you want to do it on Oracle. It's a bit more complex. So this is the algorithm that is done for the Oracle platform. So it checks that select or from whatever. Then it does some subqueries. You can see we have select star from, and then a subquery to count rows and so on. Because Oracle doesn't support the limit keyword, apparently doesn't support the limit keyword. So this is how Doctrine manages to paginate a SQL query on Oracle. So again, if you specify the query limit and offsets, it generates this weird SQL query to calculate the limits and the offsets. And if you check for SQL Server, it's even more complex to do. So I encourage you to read the code from Doctrine. It's very interesting. There's a lot of design patterns implemented inside the Doctrine library. It's quite useful. That's an example where you can use these template method patterns. Symfony also has this example. In the security component, when you want to authenticate, the process of authenticating a user must follow some required steps or conditions. But still, you may want to implement your own authentication system. So Symfony still allows you to do it, but you must fulfill some condition or some steps. So this is why we have in Symfony this base class, abstract authentication listener, with this handle method. And in fact, this handle method is public and final. This is the template method. But still, if you want to implement your custom concrete authentication listener, you will be allowed to override or to implement this method called attempt authentication. So we have different implementation of authentication listeners in Symfony, like using username and passwords, or maybe using a token, or using an SSL certificate. It depends. So you have different implementation, and you can also provide your custom homemade authentication system. So this is how it looks like in Symfony code. We have this handle method, final function. This is the template method. It does a lot of things before and after, but still it allows you to do the attempt authentication here. So you have to implement this method if you want to provide some sort of authentication algorithm. And the contract says that you must raise authentication exception if it doesn't work. So if you can't authenticate, then you will throw authentication exception, and then the system still has to endure this exception, this authentication exception. So this is why you are not allowed to completely override this handle method. Otherwise, you would break Symfony security system. So this is a very simple one that I've created. So I just extend this authentication listener, then I override this method, or I implement this method, and I will try to authenticate the user based on the username and password I found from the request object, from the post request. Right. And then it generates some token, and I will try to authenticate that token with some Symfony authentication token manager. Another implementation is like, let's say you want to create your own single sign-on system. Then you could just create your new class and implement it yourself. So again, Symfony allows you to just implement one piece of the algorithm, of the whole algorithm, but you can't override the whole thing. All right, so it's a very easy to implement algorithm. The fact that the class, the method is final, it prevents it from any changes, so you are safe when you use this algorithm. You know that at some point you can change this algorithm without apparently breaking the subclasses. The thing that you may break is Liskov substitution principle if you don't fulfill exactly the contract, like the input and the exception that are raised. So you have to be sure to fulfill this part of the contract. So if the methods of the steps expect that you write some very specific exception, make sure that the concrete classes also throw those exceptions that are expected by the parent methods, the parent final methods. Right, make sense? Okay, so I will finish with this one, visitor, which is also quite interesting. Not very, as you will see, it's not very easy to implement in PHP due to a PHP limitation in the object-oriented model. If you were familiar with Java, or if you have played with Java a bit, you know that in Java you can implement the same method multiple times in a class, but with different signatures. And this is why we have the visitor pattern quite extensively implemented in Java, because visitor mostly rely on the fact that you can have multiple signatures of the same methods, while in PHP we can't. So implementing visitor in PHP is a bit limited due to this design problem. However, the visitor patterns allows you to separate the data part of an object from the operations you can apply on this object. Okay, so the goal is to have the data on one side, the operations on the other side on different objects. The goal is to mostly fulfill the open-close principle, which means whenever you need to have a new operation on your data object, then it's just a matter of creating a new visitor that will visit this object. And of course, as you will create a new class, that means you will have a new responsibility. So each new operation is a new responsibility as we have a new class for it. It's a very straightforward pattern to implement. So as you can see, we have the element. So the element is the object that we want to visit. Okay, so this is the visitee object. And the visitee object simply must expose an accept method, which accepts a visitor. And a visitor is an object that will visit the element. So it's a two-way relationship. So basically, the accept method, when you enter the accept method, you just directly call the visit method and you inject yourself into the visit method. This is how it works. Again, the doctrine library has a very useful and smart implementation of this visitor design pattern. This is how doctrine allows you to visit a schema and detect whether there are changes to your schema. So whether you have added new columns or new indexes or new tables to your schema, or in the opposite, where you have if you remove columns or if you remove indexes, the visitor will detect it and will generate just the SQL that is needed to update your database schema. So this is the visitor interface. So if you want to visit a doctrine schema, this is what we have. We want to be able to visit the schema, the whole schema, or we want to only visit a table, or we want to visit just a column of the table, or we want to visit just a constraint, a foreign key constraint of the table, and so on. This is the, so this one is, so this is the element, so this is the visitee object. We want to be able to visit a schema. So as you can see, the schema exposes a visit method, which accepts a visitor. And so the schema object is a complex object because it contains tables model, it contains foreign key models, it contains columns, and so on. So we will make the visitor accept the schema, and then we will also check if we have tables or sequences and so on, and then we will also make the visitor accept the tables and columns and foreign keys and so on, so that the visitor can get information from the database schema. Right. So you can see the visit method is quite long. It allows to visit columns, indexes, foreign keys, and so on. So it's very smart. And now we have the visitors. because we don't want to have the complexity of visitors inside the schema object. The schema object is just a data object, and all the operations we want to achieve on this schema are extracted in a separate visitor classes. Like for instance, there is a visitor. As you can see, it extends some abstract visitor class. And so this visitor is responsible for generating all the drop SQL statements when you visit the schema. So whenever you drop a column, whenever you drop a foreign key, whenever you drop an index, this visitor will detect it and will generate the corresponding SQL code for dropping this element from your schema. So we have, as you can see, we accept the table, we accept the foreign keys, we accept the sequences. So it just does some operations. And at the very end, let's probably get drop. Oh no, this one. Let's say this is here. At the end, you have this method. So get query. So your visitor exposes a get queries method, and this method will generate all the drop statement for the platform, because whenever you are on MySQL or Oracle or Postgres, you need to generate the right SQL code for dropping stuff. And so this is how it does. We first collect all the dropped columns, tables, and so on, and then we generate the SQL code for the corresponding platform. There's another one here, single database synchronizer. So this one, what is get the schema? Yeah, so this is where we use the drop schema collector visitor. So as you can see, we get the schema, and then we ask the schema to be visited by the visitor. So this is where you what I'm saying. Yes, I have another example which is much simpler than this one. Yeah. So remember the web shop. Do we have this here? It's not here. Yeah. So let's say you would like to, at some point, visit your products to gather information about your products. So remember our physical product. The physical product has a price. It has a unit price. And you would like to perform operations on your products, like maybe you would like to collect the different distinct categories of products, or maybe you want to collect all the prices to make some statistics. Maybe you want to know how many products has a unit price less than maybe 100 euros, and which one have a price which is higher than 500 euros, and so on. So let's say that I would like to locate in a shopping cart whether or not the shopping cart contains luxury goods. And so maybe a luxury good is a product which costs more than X euros, for instance. I don't want to put this operation in my product class, because at some point I would like to have new rules on my products, and if I keep adding new methods to my product class, I will end up having too many responsibilities inside this product class. So instead, I want my product to be visitable by a visitor. So this is why here we have this accept method. I want this physical product object to be visited by the product visitor object. And as you can see, it's very simple to implement. You receive a visitor, and then you trigger the visitor by calling the visit method on the visitor, or visit product in this case, and you inject yourself into the visitor. There is one limitation of using the visitor pattern, is that your object must have public methods, or expose the state with public methods if you want to read it. Otherwise, you will have to use the introspection API or reflection API to introspect the object, which is quite not efficient. So when you use the visitor pattern, your data object must expose the state in some way using public attributes or public methods. That's the main limitation. And so that's the call to the visitor. And now we have the visitor class, which is one operation. So this is the interface, as you can see. My visitor can visit just a single product, or he can visit a combo package. So in our case, it's combo here. Product package is in fact the combo product that we designed yesterday. So I want a visitor to be able to visit any product or any combo. And for any new single operations I want to achieve on products, I will create new visitor classes. Like for instance, I want to find any luxury goods inside a package, for instance, or any product. Is the product a luxury good? So let's say that this visitor will be initialized with the money threshold that decides that if the price of the product is at least this threshold, we will consider it a luxury good. All right? And then I will visit the product. So I will get the price, I will get the unit price from the product. If the unit price of the product exceeds the threshold, then it's considered a luxury good. So I will store it somewhere in the visitor. And of course, as you can see, the property like luxury goods property is an array, so we have at some point to expose it outside of the visitor so that you can read it. And this way, I don't know if I have maybe a test somewhere. Yeah, visitor. So this is my object. So product package. As you can see, we have different products with different prices, and we will consider that the product is considered a luxury good if it has a price greater than 100 euros or greater or equal than 100 euros. So inside the package, in this case, in this package, we have 15 euros, 9 euros, 128 euros, 15 and 565 euros. So if I want to extract all the luxury goods in this package, then I can run this visitor on my combo package, and then in the end, the visitor will collect all the information, and I will be able to know in this package which products are exactly luxury goods. So for any operation you want to apply on your products, then you just create a new visitor. Maybe you want to, let's say, gather all the prices to generate the currencies prices. Maybe you want to convert all the prices into several currencies because you want to deal with Euro and USDs and something else. Then you could make a visitor which recalculate all the currencies, all the prices in different currencies, so that you can store the price of your product in several currencies. Or maybe, I don't know, you want to discount the prices of some very specific type of products. You decide that for a promotion operation, you want to discount all product from that particular category of product. Then you will make a visitor, which is configured to iterate over the list of products. And if the product matches the category, then you discount the price, you reduce the price. So it's very simple to use this visitor pattern. It's very flexible. There are two downsides, so as I explained. The first one is that your visited object must expose their state with public attributes or public methods. So that's one limitation if you don't want to expose too many information to the outside world. And the other limitation is that a visitor will have at some point to store states like this one. As you can see, we have to store the luxury goods that we found. So the state of the visitor will be mutated. So that means this visitor can only be used once, because if you run it a second time, you will have to reset it first. So you will have to take care of either resetting the state of your visitor using a reset method, or reinstantiating it to ensure that you start with a fresh state. Right. So that's the main limitation of this visitor pattern. But it's very convenient and easy to separate object containing data from the operations you can apply on these data. So you can get this code. There's another repository. It's called Symfony Live-2018. This was the workshop also I did at Symfony Live in Cologne. So if you want to get this example, it's also in this repository. This one. Any questions?
And when we should do that, some attributes or some behavior or what show us that we need to apply visitor?
Yeah, it's mostly useful when you have to deal with very complex object graph, usually nested object graph. When you have when you have complex nested object graph, and you want to perform many different types of operations on these objects, that you don't want to put those operations into methods into your data object classes, because in the end you will have too many responsibilities. You will have both the pure data and the behaviors or the operations you want to apply on these data. I think I have some. Yeah, I have. I may have an example. This one. I know that I used to present it. This slide deck. I have another slide deck where I have this visitor pattern explained in a simpler way. This adapter. These are all the slide decks you can also find in my speaker deck page, so they are published anyway. But was it in? Where did I do this talk? This one. Oh, maybe this one. Yeah, should be this one. Yeah, can show you. You'll have pretty better understanding. Blah 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 blah. Yeah. So this is an example with a shopping cart. Let's say you have a shopping cart, and then in the shopping cart you will put some shopping cart items. So a product reference, a unit price, and a quantity. And at some point you want to perform operation on this shopping cart. So let's say that I'm adding items, like I'm adding tomatoes, let's say apple, shampoo, and so on. So we have different types of products in this shopping cart. And as you can see, we have the categories, so vegetables, seafood, wellness, whatever. And so at the beginning, you start with this kind of implementation. My shopping cart class has items, and now I want to perform operations on this shopping cart. I want to get the total price of this shopping cart. I want to reorder all the items by categories that are in the receipt. On the receipt, I can have the category, all the items in this category, and second category, all the items in this category, and so on. And at some point, I also want to issue the receipts. And for that, I need to inject some PDF generative object to do it. The thing is, if you do that, as you can see, you start bloating your shopping cart class with too many responsibilities. That's a responsibility. That's another one. That's an even more complex responsibility, because we have a dependency with some another object which performs some complex stuff. And maybe at some point you want to introduce a a way to discount the shopping cart. So you will have another method to perform a discount with a coupon code, for instance. So when you have this situation where you have a data object on which you want to apply operation of different natures, they are completely different from each other, then it should be an indicator for moving the code, for moving the operations into separate classes. And keep your data object as a pure data object, like in this one. So in fact, those three methods will be extracted as visitors. So instead, I want my shopping cart object to only accept visitors. So the shopping cart will just contain the items I put in the basket, and all the operations on the basket will be done through visitors. And so this way I will decouple the data from the behaviors. So for instance, we have this visitor, the visitor which calculates the total price of this shopping cart. So when the shopping cart is visited, we will simply iterate over the list of items, and then we will calculate the total price of this shopping cart. And then my visitor will expose some method to know this total price. All right? So it's simple as this. We have the cart where we add items, and at some point I want to know what's the total price of this shopping cart. So I will simply make my shopping cart accept the total price cart visitor, and that's it. Then with the visitor, I can retrieve the computed total price. Now we want to sort all items by category. So that's a very specific operations I want to achieve. So again, to do it, I will just offer a new visitor for this particular operation. So as you can see, I will iterate over the list of items, and then I will have a sorted list by category so that I can know which items belongs to which category of products. And again, I will return a sorted list of shopping cart items. And that's simple. Again, my shopping cart will accept this new visitor. The visitor will collect the data, and I will be able to read the computed data from the visitor. If you want to generate the receipt, then you will have a generate shopping cart receipt visitor, which takes the PDF generator dependency, and you will make your cart accept the visitor, and then the visitor will compute the PDF files. And your shopping cart object doesn't know anything about PDF generation or storage engine or whatever operations you want to do on this shopping cart. Right? Yeah. Thank you very much.